All right, this is the start of section 3.2 in your Math Links 9 textbook. And we're continuing on with the idea of exponents. And this time in section 3.2, if you wanted to give it a title, you can call it section 3.2, we'll call it exponent laws. Exponent laws or rules or different ways of thinking about what would happen if exponents were done to other exponents or powers to other powers with multiplication, division, or exponents. So we actually have 5 different rules we're going to learn here, 5 different laws, Andrew. And the first one, if you want to put it in your notes, you can call it SYK1. And you can actually call it, if you wanted to subtitle this one, we can call it uh, Rule 1 or Law 1. Uh, multiplying powers with same base. Okay? So Law 1 or Rule 1 or whatever you want to call it has to do with multiplying powers that have the same base. Okay? And we're going to look at exemplars here, and then we'll see if we can come up with a rule together. Now the first one, A, says 4 cubed multiplied by 4 to the 5. All right? So if I grab my marker here, my highlighter, and I highlight what 4 cubed would look like. What would 4 cubed look like in repeated multiplication, Brian? What would 4 cubed look like in repeated multiplication? 4 times 4 times 4, correct. 4 times 4 times 4, so keep that in yellow. And then we'll have multiplied by, I'll use a different color, I'll use green, 4 to the 5, which if we keep what Brian was just saying will be 4 multiplied by itself 5 times. I'll highlight that in green. Does everyone agree that 4 cubed multiplied by 4 to the 5, when I rewrite it, instead of using exponential form, if I use repeated multiplication form, that's what it would look like? And then I got to ask yourself a question. If you look at that and say, well, what if I gave you, and I'll just remove the highlights here, what if I gave you that question and said, write that in exponential form? What would you have written? You would have written 4, because that's what's used in repeated multiplication, multiplied by itself 1, 2, 3, 4, 5, 6, 7, 8 times. Would you agree with that? So based solely on this work here, can you make a law yet or a rule that governs what you do or what's a shortcut you can do when you multiply 2 powers together that have the same base? Brian, what would you say? Correct. So Brian says it appears that you can keep the base and add the powers. Or another way to say that is if you have 4, 3 times 4 to the 5, you can keep your base and add your exponents to get the answer or the simplified answer of 4 to the exponent of 8. It seemed to work on this one, didn't it? Let's check it out with the second one, B. This time our base is negative 5 as defined by the brackets. And we have negative 5 squared. Oh, you know what? I actually went too fast. Let me erase this, come back to it in a second. It says to solve it 2 ways, doesn't it? What's another way I could have solved it? This is one way to solve it. Another way I could have solved it is simply convert both of those to standard form. So just treat it like a bedmass question where we have exponents and multiplication. So 4 cubed is 4 times 4 times 4, which is actually 64. So we can put 64 here instead of 4 cubed. Multiplied by 4 to the 5th, 4 to the exponent of 5. 4 to the exponent of 5 is 1024. And when I work that out with a calculator, 64 times 1024, it gives me 65,536. Now, if this is correct, you all agree that this also should be 65,536, right? So if I take a calculator and go 4 to the exponent of 8, it actually works out to be the same answer, okay? So the two methods we could use here, the first method that we did here was simply using that sign rule, repeated multiplication, then rethinking of it as an exponent. The second way was to simply solve it using bedmass, do your exponents first, then multiply it and get it into standard form. If we use that same logic, now we're on B, back to where I should have been earlier. Negative 5 squared, negative 5 is your base, multiplied by negative 5 as the base cubed. Let's reverse it. Let's do rule 2 first. Does anyone know what negative 5 squared is in standard form? That's an easy one. Is it positive 25 or negative 25? Positive 25. Multiplied by, does anyone know what negative 5 cubed is? Just multiply 25 by 5 again and add a negative sign, right? Negative 125, right? And when I multiply those two out, 25 times negative 125, I get negative 3,125. That's the first method you could have done, is that's just changing it to standard form and using BEDMAS to simplify. Alternatively, negative 5 squared is negative 5 times negative 5, multiplied by negative 5 cubed, which is negative 5 times negative 5 times negative 5. Or, simplified, it would be negative 5 as a base, multiplied by itself 5 different times, which if I use a calculator now and simplify that, negative 5 as a base at your XY button to the exponent of 5 is still uh, negative 3,125. Okay? So rule 1, we're going to write it down. It's kind of anticlimactic. When multiplying powers with the same base, and that's important, you might want to double underline it. It has to be the same base. When multiplying powers with the same base, you can keep the base, comma, and add the exponents. All right, our second question, if you want to call SYK2, it's going to be rule 2, has to do with division, my division is in division of powers with like base, with like bases. So if we look at exemplar number A, the first one, 2 to the exponent of 5 divided by 2 to the exponent of 4. Now the first way we can solve it, because it says 2 different ways, just like we did in the last question, I can actually simplify into standard form what each power is worth. 2 to the exponent of 5 is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. Divided by 2 to the 4 is 2, 4, 8, 16. And what is 32 divided by 16? It is 2. So the first thing we could say, actually, does anyone know what, if 2 is a power, what is the exponent that's not written for 2? Is there an exponent on 2? There is actually, it's invisible. Is it 0 or is it 1? It is 1. It is 1. And we'll talk about what exponents of 0 are later on. But right now, we're going to say that when you do that, you end up with an answer of 2, or in exponential form, 2 to the exponent of 1. In the second method, if I think about 2 to the 5 divided by 2 to the 4, but I re-envision it, does everyone agree those are the same thing? Right? First thing I need to get your mind around is what sometimes we have division looking like. And for this particular question, it's going to be better if we look at it this way than if we look at it as a straight division question. But you need to understand they're both the same thing. So if I was to think of this as maybe a fraction instead of a division, would you all agree that's 2 times 2 times 2 times 2 times 2 divided by 2 times 2 times 2 times 2? Does that make sense to everybody? If I had that as a multiplication statement and I multiplied those 5 2's on the top and those 4 2's on the bottom, I would end up with this question. Would it affect it at all? Would my answer be affected at all if I put a times 1 there? Consider that for a second. Does that change the value of the bottom at all if I do that? No, it doesn't. Does it? I'm going to keep it there because I have 5 terms in my top and 5 terms in my bottom. Now here's another question. If I gave you this as a really long fraction question, and I asked you to show your work like we did in the last chapter, would you show your work like that? Well, if I asked you, do you remember in the test I said make sure you show your steps? Multiply your numerators, multiply your denominators, right? If you were doing that question. So if this was the question, this is what you would have done, and you could have reinterpreted it this way if you needed to, kind of going backwards in time. I'm starting from going backwards. But what is 2 over 2 really worth? What is this 2 over 2 really worth? It's worth 1. So essentially, multiplying by 1 doesn't matter. So we can kind of say it cancels each other out. 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 What am I left with? Just 2, or 2 over 1, or, more importantly, the same answer I got last time. Okay? Now, I know this is kind of complex. This is the most difficult one to kind of show the why behind. But once you write it out and you see it, you're like, okay, this kind of makes sense. I get this. I get why this works. It gives me the same answer as 2. If I look at the second exemplar, B, and this time it's negative 3 to the 10, negative 3 to the 10, divided by negative 3 to the 7? 7. Negative 3 to the 10, if I do it the first method, is going to be a big stinking answer. By the way, if my base is negative and my exponent is 10, should my answer be positive or negative? If my base is negative and my exponent is even, this should be a positive answer, right? And the answer is 59,000, or 50,000, oh, sorry, 59,049. 59,049 divided by negative 3 to the 7 should be a negative number, right? Because it's an odd exponent. Divided by negative 2,187. Does anyone know what this is right off the head? Can anyone guess what this is using your brain right now? Somebody think this through. Real quick. Not hard. You should be able to do it. Anybody but her. Anybody but her. I'm just joking. I'm just joking. Okay, Sophie, what is it? It's negative 27. Now, how in the name of God did Sophie do that so quickly? Do you think she actually did this division? Do you think she actually divided that in her head? No. Do you think maybe just for a second she might have used that sign rule and figured out that what you do is you actually subtract your exponents, and the answer should be negative 3 as a base to the exponent of 3, in which case negative 3 times negative 3 times negative 3 is negative 27. Do you agree? That's how she did it. She's not a super genius. She's just very observant. Watch. 59,049 divided by 2,187 negative equals negative 27. So here's what she did. Here's what she did. Because you're dividing these two numbers, this is what it looks like. That's the same thing as negative 3 to the 10 over negative 3 to the 7, which is, this sucks because it's really long, negative 3 times 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 negative 3. Is that 10 of them? Yes. Divided by negative 3 times 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 negative 3. How many is that? 1, 2, 3, 4, 5, 6, 7. Good. If I put a line through it, why did I do that? Because it makes a 1, doesn't it? What about this one? And that 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 one? What am I left with? Negative 3 cubed, right? Which is negative 3 cubed is negative 27. Okay. So your rule is this. Rule 2. All of that was just to write this rule. When dividing powers, with the same base, comma, keep the base, and subtract exponents.